Good morning everyone, welcome to my presentation. My name is Maroš Mojto, I am PhD student from Slovak University of Technology in Bratislava. I am delighted to be here today to tell you about slip joins used in the construction of masts. This work is done in collaboration with the ELV Product Corporation. Our research is still only in an early stage, but I would like to show you some of our interesting findings. My objective today is to introduce the verification of the FEM model by experimental measurement. My talk is divided into the following parts. First, I will talk about the background information, then I will look at the experimental measurement and FEM model, and finally I will present the results and comparisons. Let me start with some general information about the research topic. Slip joins find usage in many industrial applications such as electricity poles, lighting poles, or even flag poles. It appears that the behavior of slip join is quite simple. The upper part slides over the lower part on the overlap length. The slip joins make an alternative solution to the traditional flange connections. The main advantages, opposite to flange connection, are saving material, assembling time, and additional costs. Despite the indisputable benefits and well-historical performance, the use of slip joins is limited. Why is that so? We suppose that is due to the lack of the design manual. The only request to be satisfied is minimal overlap length that is related to the diameter. The design manual doesn't include the aspects considering the overlap length, conicity, stiffness, or imperfection. We are dealing with the before-mentioned aspects in our research. After verification of the FEM model, the effect of the parameter will be obtained just by simply modifying the FEM model. This leads us to the next point, which is experimental measurement. This is the first input for the final comparisons. The experimental measurement consisted of two conical 8-edged steel pipes. First, the experimental 0-1 has been carried out with an overlap length equal to 3.1 times d, where d represents the diameter of overlap length. After a cut of the upper part, the experiment 02 has been executed with overlap length equal to 1.75 times d. The measurement is done by sensing devices such as strain gauges, displacement transducers, and load cells. What I want to highlight, we use achieved skills from the experiment 01 in the experiment 02. While the first experiment has strain gauges placed along the entire overlap length, the second experiment has the strain gauges placed only in the expected most stressed zones. Let me explain this in the following figure. You can see the blue cross mark for the position of strain gauges in experiment 01. Now you can see the position of strain gauges for the experiment 02. Moreover, the second experiment involves 2 times more strain gauges than the first experiment. Finally, the results have been collected using hardware Spider 8 and evaluated with the built-in software Catman. Well, that's all from this part of research. Let me now turn to the FEM model. A numerical model has been carried out in the software Global. The contact area between the upper and lower part is active only in compressive with the possibility to define friction. This you can see in the figure on the right-hand side. Now we have both numerical and experimental inputs to the final comparison. Let me now turn to results. Before moving on to first results, I would like to reiterate what I said about compared stresses. As the figure illustrates, the tangential stresses are listed in the middle of the wall. Now let's have a look at the comparison in the figure on the right-hand side. The results from the numerical model are presented by green curves and from the experimental measurement by red curves. These results show that it is possible to indicate a discrepancy between numerical and experimental values. To return to my early point, we assume that the reason for this discrepancy is the lack of strain gauges in most stressed zones. The benefit of these findings is the similar behavior of curves. We can see that the shape of different curves is similar mainly on the top of the walls. Now we can move to the second comparison, which is between experiment 02 and the corresponding FEM model. One of the results from a numerical model is on the left-hand side of the following figure. The comparison is presented by the graph on the right-hand side using the same methodology as before. It seems that the results indicate higher similarity between the numerical and experimental results compared to the previous comparison. But there is still discrepancy mainly on wall A. This brings us to the next point of the presentation, which is going to be about how to make FEM model more accurate. Before moving on to the next comparison, we can see on the left-hand side manufacturing imperfections. These imperfections have been incorporated into the FEM model. You can see the final comparison on the right-hand side. It is possible to conclude that the applied imperfections make the comparison more similar. It seems that our results show that the residual discrepancy might be caused by another non-incorporated imperfections. To return to the original aim, we can confirm the verification of the FEM model. Okay, we are very close to end now, but let me briefly inform about the possibility of using the verified FEM model. Based on the FEM verification, has been carried out the parametric study considering the aspect of overlap length. This study you can see on the following figure. How it is possible to use this study? In the next table are presented values obtained from the experiment on the onshore wind turbine. The author states that the measured tangential stress is about 9 to 13 megapascals. If the values are used in our parametric study, the result of stress is about 30 megapascals. This brings us to the summarization. Based on the provided comparisons, it appears that the numerical model behaves according to experimental measurements. And what we are planning to do next? We will carry out the other experimental measurements to increase the accuracy of the numerical model. We are also planning to incorporate imperfection from a more complex point of view. I'm afraid that I don't have time to go into this in any further detail. If you would like more information on this topic, then please feel free to email me. Thank you for your attention.